There we go, it's working. All right, it's good. Okay, this last section of the topic is called the reverse chain rule, and the whole first page is explaining where the formulas come from. You do not need to be able to regurgitate this, but it's just to give you a bit of history. Where does it come from? Why are we doing this silly process? So, when we did differentiating last year, we learnt the chain rule for differentiating. And it was when I have something in brackets, so some function in brackets to the power of n. When I want to differentiate it, the n comes down the front, the function stays inside the bracket, I subtract 1 from the power, and I multiply by the derivative of the bracket. Now, we often did the derivative of the bracket up here first, but it does have all the things that we did in our chain rule. That can also be written in this form. So instead of saying it's y equals, it's saying the derivative of my function to the power of n, bring the n down, keep the function, subtract 1 from the power, and multiply by the derivative. It's just this part here at the beginning that's changed. So if y equal, it's just changed to find a d over dx of this thing. So what we're trying to do is we're now trying to reverse this, which is why it's called reverse chain rule, to go to integrate something that is in brackets like that. Okay, remember I did show you one process, but it only worked for the very simple types. This can be used for harder things with more things around those brackets. So there is 2 sections here. Let's start with this first one. If we wish to reverse the formula, we're going to start with, just copying down that bottom line again. So I'm starting with that derivative, and I want to go backwards and try and find out what happens when I reverse that and go back to the integral. So what I've done is I've just put an integral sign on each side. I'm going to integrate both sides. That's reversing, right? When I integrate, the integral next to the derivative cancel each other out. Integrate, differentiate, cancels out. So I just get the function to the power of n. The other side, when I integrate, actually I haven't even integrated it yet, I'll do that in the next part. All this other side has done is move the n to the front of the integral sign. Because it's a number, just moving that out of the way. So then, final part, if I want to integrate this bit, I'm dividing the n, taking this n here, and moving it across to the other side, so that it's my function of x to the power of n, dividing that n is equal to this integral. Okay? What on earth does that mean? The second part that is here, this is the exact same steps again, but instead of using n, they've put n plus 1 everywhere, so that in your formula, we're used to, when we integrate, adding 1 to the power and dividing by that power. This looks like a lot more like what we're used to seeing for an integral formula. So what it means is, if I'm trying to integrate a function, so something in brackets, with some power of n, what I need is to have the derivative of the function next to it. If I can have that derivative next to it, you basically ignore the derivative, and all you have to do is keep your bracket, add 1 to the power of your bracket, and divide by your power of your bracket. Sounds very simple. The formula looks gross, but the process is hopefully much simpler. Okay, here it is again in another form. Extension people, the use of the letter u will be something that we will do a lot. Integrating by substitution, we'll be putting u's in to help us integrate things. So instead of calling it f of x, we're calling it u to some power of n. And as long as the derivative of whatever u is next to it, you ignore that derivative, and I just add 1 to the power of u and divide by the power of u. Okay, different form. Here are those formulas in the function form or in u form. down there at the bottom of the page. Okay, so let's do it. Example 1. Use the formula for reverse chain rule to find the integral of x squared times x cubed plus 5 in brackets cubed. Now the function, the f of x that I've been talking about, is this thing in the bracket. It is the x cubed plus 5. Okay, I'm going to even write that over here on the side. I'm going to call it u because I think u is much shorter than writing f of x all the time. Is that okay with everybody? I'm going to use the u version. So the u is the x cubed plus 5. I need the derivative of that to be this thing that's with my integral. Now, let's just check. What is the derivative of u at the moment? If I differentiate that, du with respect to x. 3x squared. Good. Okay, so the question that I've been given is not as nice as we would like. It's not perfect. I have got the x squared, but I need there to be a 3 there as well. So I'm going to modify my integral. So here is my original question. I'm integrating x squared bracket x cubed plus 5 cubed dx. I need it to be, this is what I need, 3x squared x cubed plus 5 to the power of 3 dx. I need that derivative to be in front of my bracket for me to use my reverse chain rule. Okay? But I can't just randomly chuck a 3 into my integral sign. If I put an extra multiple of some number in there, I have to compensate for that. Anyone want to think how I would compensate for that? Put what on the other side? So I'm going to multiply another 3 here. Over here, where am I putting the other 3? No, I don't think you're quite there. Any other suggestions? You want to divide the whole thing by 3 or put 1/3 out the front, because the 1/3 times the 3 would cancel each other out and would be the same as this integral back here. Okay? But this purple part is the integral that I need. That third can just stay sitting out the front while I do the rest of my reverse chain rule. Okay, so to do the reverse chain rule, the third is not a part of it, so it's sitting there. The derivative, because that's the right derivative, I'm going to chop that out now, I don't need it. I'm going to take this bracket, I'm going to add 1 to the power and put it over the power. So it will be x cubed plus 5, add 1 to the power is a 4, and put it over 4. Technically, I should have a times sign in there, so I'm timesing that with the third that was already there. And the other thing I should probably have is my plus c, or you could leave the plus c for the last line. On my last line, all I'm going to do is times that third in with that 4 to make it one big fraction. So x to the power of 3 plus 5 to the power of 4, all over 12 plus c. And that's the reverse chain rule. Okay, let's try it again. Question 2. So it tells me in the question that I need to use the reverse chain rule. So as soon as you know that, you're looking for what is my function, and I need to also then know what the derivative of that function is going to be. So what do you think of my stuff over here? What is my function? The 1 minus x squared. It's the stuff that's in the brackets, or square roots work like a set of brackets because it's brackets to the power of a half, isn't it? Okay, so I'm going to call that the u, 1 minus x squared. Then I need the derivative of u, so du over dx equals minus 2x. Again, not perfect. I don't have the right stuff in front of this x. I have the x, which is important. You can't just add extra x's in. It's only ever numbers that you can fiddle around with. You can't do stuff with x's, okay? So I do have the x, but I need to put the minus 2 in there. So I'm going to modify my integral. I want minus 2x square root of 1 minus x squared dx. But I've modified it by putting this minus 2 in. What am I going to do to compensate for my change? Negative a half. So I'm going to put that out the front. Negative a half. Because they cancel each other out and give me my original integral. Okay, then to integrate it, the negative half is going to sit out the front. This is now function and its derivative right here. So I'm going to, actually before I do, I need it in bracket form first. I need an extra step, one extra step, because I can't integrate while it's in square root form. Let's change it into brackets. It'll be bracket 1 minus x squared to the power of a half. Now I can do it. Leave the minus half. The derivative gets ignored because once it's correct, we don't need it anymore. I keep this bracket, add 1 to the power, divide by the power. So it's 1 minus x squared. Adding 1 to the power is 3 over 2. And I'm going to divide by 3 over 2, but what's my shortcut? Flip that fraction to be a 2 on the top and a 3 on the bottom. And then plus your c, or we'll do that on the next line. To bring that together, I can cancel 2 on the top with 2 on the bottom. So my answer would be negative. I'm going to leave it in bracket form, which is not normal. Normally I would change that back into surd form. The reason I'm not, well, I could. There's a part B here. We'll want to do it in surd form as well, just for practice. What is that in surd form? It's minus the square root of, I don't need the 2 because it's a square root. 1 minus x squared to the power of 3 all over 3. Okay, that's just a little bit yuckier to sub stuff into, so that's why I'm going to use this version for my next part. Question B, it says use the reverse chain rule to find the integral of x square root of 1 minus x squared dx. That's the exact same question, but this one has numbers on the integral. So this is an indefinite integral. Got the plus c. I now want to do the same thing. I don't have to do the process again. I already know what the integral is, but I now want it to be a definite integral where I can sub the values in. So taking my answer, which was the minus 1 minus x squared to the power of 3 over 2 over 3. And I'm just putting the 0 and the 1 on the ends of those brackets so that I can sub those numbers in. No, this is not all plus c because I now have the numbers to sub in. Changing it to a definite integral. So subbing in the 1, we get minus 1 minus 1 squared. Oh, that's going to be 0. So that whole first thing is 0. Then I need to subtract and then minus 1 minus 0 squared, which is 0 to the power of 3 over 2. So that's still 1 over 3. So as I said, that's all 0. 1 minus 0 is just 1, and 1 to any power is still 1. So it's just 1/3, positive or negative. Minus here and minus here. Positive 1/3. And that's without a calculator. Look at that. You can type in your calculator if you like. All right, the end. The end.